This is page 100. And to me, problem 13 is a little bit of a challenge. It's a little bit more than what we've been doing. And the reason is that you're going to need to know a piece of information that we haven't talked about on these videos. And that is this. So make yourself a box or something out of the way. And in that box, put this information. Apparent power is equal to reactive power divided by a power factor, the power factor. We're going to need that here in just a second. So let's move slowly on this problem. A load has a reactive power of 120 VAR and a power factor of 0.8. Find the real power. So we're looking for W. Now we have talked about in the videos that power factor is equal to true power over apparent power. And in our language, we would say W over VA. So I'm going to take this form of the formula out. I don't want to confuse everything any more than it's already confused. And it's not wanting to cooperate with me, but here we go. Now, we know power factor. They told us that it's 0.8. They want us to find W, but we need to know VA, and we don't. So if we knew VA, we would just plug it in there and be done. But we don't know VA. And that's where this red formula comes in. Because knowing the red formula, I can find VA. I know that VA is equal to the reactive power, which we know to be 120, over the power factor, which is 0.8. So when I do this math, 120 divided by 0.8, I'm going to get 150, and that is VA. So I can bring that in here for VA, and we can finish this problem. We have to multiply both sides by 150. And that would leave me with W equaling 120. So real power is 120. But the key to this problem is that information in red. If you don't know this, you cannot solve the problem this way. So I had to know that formula to be able to get that 150 to plug into the formula that I needed to solve. So this one's a little bit of a challenge. If you understand this, you should be very proud of yourself. This is a tough one. It goes a step beyond what we've been doing. If you have questions about this one, talk to your instructor or watch this video a few times and it should help. Number 14. A circuit has a real power. Let me draw some colors here. I should have done this on the last one, but I won't go back and do it now. A real power. Where would you put real power? That's W, so that's going to be down here. Of 400 W. And VAR 300 for reactive power. And they want us to find the phase angle. So they want us to find theta. So I know I'm going to need an arc function to do this. I don't know which function it's going to be until I consider SOHCAHTOA. So let's set up H, O, A, theta. We don't know hypotenuse. We don't want to know hypotenuse. I can tell you that it's VA. Opposite is 300. Adjacent is 400. And we don't know theta. I could easily tell you hypotenuse, and I bet you can too. Let's go ahead and do that. If the legs are 3 and 4, what's the hypotenuse? Remember those Pythagorean triples? It's got to be 500. So I can tell you hypotenuse is 500, but I still don't know theta, and that's what we're looking for. So using O and A, that's TOA, I'm going to say the tangent of theta is equal to opposite over adjacent. And this is where we have to use arctan. And let me slow down. Your calculator will do arctan. It looks like this. Well, let me just not get up there. Bear with me here. All right, we can cancel some zeros and get this down to 3/4. So theta, let me try to show you how this works. I'm literally breaking tangent away from theta. Okay? And when I do that, we're going to get a function called arctan. So we get theta is equal to arctan of 3/4. Boy, this page is just a lot of fun, isn't it? This one should have been a bonus page. We will get back to some more normal ones. All right, so to put this in your calculator, and I don't know that you even need to know how to do an arc function. That would be something to ask your instructor if it's important. If it's not, I wouldn't worry about this too much. But as the person who is drafting this course, I need to be sure that I include it if it is important. Okay, and I'm trying to get calculator buttons. I don't want this to get mixed into your problem. I believe it's 6 buttons, but let's see. First one is always all clear. Last one will be equals. So then you put in 3 ABC, or you could use 0.75 here if you wanted to avoid the fraction. Either way should work. And you press shift, tangent. And if you look above tangent, you'll see arctan. You'll see tan -1. And then your last button will be equals. And when you do that, you're going to know theta, or approximately what theta is equal to. And I'm going to say let's round it to the hundredths place. I don't know why. That's just what came into my head. So about 36.87 degrees is your missing theta. Hopefully number 15 is a little more straightforward for what we need. Let me go ahead and put in the colors. There's adjacent. There's opposite. And here is hypotenuse. And in here is little theta. So let's read our problem. A transformer supplies 500 VA, that's apparent power, at a power factor of 0.75. And we are supposed to find the real power. We want to find the W. So I do know a formula for power factor that says that it is true power over apparent power. And so if we combine these two, we could say that 0.75 is equal to true power which we don't know, but we do know apparent power. In our language, this is W over VA. Let's use that formula. I left this first one in that I'm about to cross out because it's in your book. And I wanted you to know that they are the same thing. All right, so we're going to multiply 500 to both sides. And we're going to cancel. So true power is going to be 75% of 500. And that is going to be 375. That is true power. And that's your answer.